Now, in the previous lesson, we looked at the second law. Here we have now the third law. In the third law, I want us to look at what we call negative indices. Negative indices. What are we going to consider here? So, consider. And before we consider, if you're new or if you have been watching this channel and you have never subscribed or liked any video, you are the reason why some other kids have not gotten these lessons. Remember, you are aware of them, but other kids are not aware of these our lessons. And this is the main reason why I joined Kenya Science, to ensure a certain kid somewhere who does not know maths or who believes that maths is hard, we simplify everything. So do a contribution, you as you. Just subscribe, like the video, and let the video be taken to other people. Only by after subscribing and liking. Now, negative indices. Negative indices. Let us consider now a raised to power 2 divided by a raised to power 3. Remember, negative indices. A raised to power 2 divided by a raised to power 3. How are we going to solve this? No headache. Solution. You'll say a raised to power 2 divided by a raised to power 3. Assuming I don't know the laws of indices dealing with division, what am I going to do? I will just take a raised to power 2 over a raised to power 3. That's the simplest step possible. Division means over. Next, I'll do a raised to power 2. This is the same as a multiplied by itself how many times? 2 times. So it will be a times a. Over a raised to power 3. This is the same as a times a times a. So here, what do I have? I have a times a, and here a times a times a. And this one represents a raised to power 2 in long form. This a times a is a raised to power 3 in long form. And I was told that once we are dividing and we have similar factors, we can simplify. If I simplify here, what am I going to have? A divide a, 1, a divide a, 1. A divide a, 1, a divide a, 1. So in the numerators, I don't have any a, but I have 1. 1 times 1, I have 1. Over a times 1 times 1, that is now a. Are you seeing that? So 1 over a, that is what I have. So if I have 1 over a, and I did not use the laws of indices, and I'm aware that I can now apply the second law we talked about in the previous lesson to solve this. Remember, we have said that if you have a raised to power m times a raised to power n, what do? We add the powers. This is now a raised to power m plus n. If you have a raised to power m divided by a raised to power n, this is a raised to power m minus n. I'm subtracting. So I'm aware that I can also use the laws of indices to solve this. So let us use the laws of indices. What do I have? I have a raised to power 2 divided by a raised to power 3. So this is the same as I'm dividing, bases are common or bases are the same. What do I do to the powers? What did we say? We subtract the powers. So if you subtract the powers here, it will be a into a raised to power 2 minus 3. A raised to power 2 minus 3. So here, it therefore means 2 minus 3. What do I have? 2 minus 3. A smaller number minus a bigger number, that's now the negative of the bigger number minus a smaller number. So it is a raised to power negative 1. Wow! So it therefore means that if I have a raised to power 2 divided by a raised to power 3, 2 minus a raised to power 2 minus 3, which is now a raised to power negative 1. Now, this one using the laws of indices. And this one, if I didn't use the law of indices, I just divide manually, assuming that I don't have the laws, I have 1 over A. And these answers are meaning that this is proving this. 1 over A is proving that A raised to power negative 1, they must be the same. So since we know that using the laws of indices and using manual giving must give us the same answer, we can now make a conclusion. We can conclude and say A raised to power negative 1 is equals to 1 over A. Or A raised to power negative 1 is the same as 1 over A. Are you getting that? A raised to power negative 1 is equals to 1 over A. So if A raised to power negative 1 is equals to 1 over A, wow. So where is this 1 coming from? I subtracted this and this. And here also ask yourself, this 1 is not this 1. Why am I saying that? Remember, I have 1 over A, and here A was multiplied by itself how many times in the denominators? 1 times. So I have that 1 here. So this 1 is negative here. Here we have 1 over A raised to power 1. Here we have 1 over A raised to power 1. And so it means that A raised to power negative 1 is the same as 1 over A raised to power 1. Good. Meaning that if I have A raised to power negative 2, this will be the same as 1 over A raised to power 2. Just using the same concept. 1 is here, 1 is here. But this side is negative. So these 2 must be negative the other side. And if I have A raised to power negative 3, this is the same as 1 over A raised to power 3. As simple as that. So if I have Y raised to power negative 4, this is the same as 1 over Y raised to power 4. As simple as that. So if I have A raised to power negative n, A raised to power negative n, where A is any number and n is any number. So negative index here, we have a negative index here. So the A is the base, n is the power or the index. We said that index is the power to which a number is raised. So what am I going to say here? A raised to power negative n is the same as 1 over A raised to power n. I don't need to sweat. I can testify. So this is now the negative power, 1 over A raised to power n. Let us see if we can use that to solve some questions. It is very simple. It is something that you can understand. Simplify giving answer with positive indices. Simplify giving answer with positive indices. So I have example 1. Simplify giving answer as a positive. Giving answer as a positive index. Simplify giving answer as a positive index. A, what do I have? 2 raised to power 3 divided by 2 raised to power 5. B, what do I have? 5 raised to power 5 divided by 5 raised to power 8. Easy solution. A, what do I have? 2 raised to power 3 divided by 2 raised to power 5. I am going to use the laws of indices. I cannot list everything. I am going to use the laws of indices. What am I going to have here? This now is the same as 2 raised to power. I'm dividing, powers are different, but bases are the same. Bases are the same, and I'm dividing. So I just write the base, then this is the same as 3 minus 5. I subtract. I subtract the what? I subtract the powers. So here, what am I going to have? 3 minus 5, that's now a smaller number, subtracting a bigger number, that's now negative. So it is 2 raised to power negative 2. So negative 2. This is a negative power, and I've been told to leave my answer as a positive power. As a positive power, I know what I'm going to do. I'll say this is the same as, so 2 raised to power negative 2 is the same as 1 over 2 raised to power 2. As simple as that. I leave my answer, no stress. B, what do I have? B, I have 5 raised to power 5 divided by 5 raised to power 8. 5 raised to power 5 divided by 5 raised to power 8. I use the laws of indices to solve my answer here. The laws of indices, what am I going to have here? It will be 5 common bases. Bases are the same. Then I'm dividing. If I'm dividing, it means that I add the powers here. I subtract the powers, I mean. So this is 5 raised to power 5 minus 8. So 5 minus 8, that's negative 3. So this is the same as 5 raised to power negative 3. This is a negative power, but I've been told negative index. I just leave in positive index here. So if I leave in positive index, at the back of our mind, we know that if we have a raised to power negative n, this is the same as 1 over a raised to power n. So if I have 5 raised to power negative 3, is the same as 1 over 5 raised to power 3. Simple. I leave my answer as that. I don't need to worry. Now, you can also try yourself with this. Simplify, giving your answer as a positive power. Simplify giving your answer as a positive power. This is x raised to power 2 divided by x raised to power 4. That is A. B, what do I have? I have 9 raised to power 12 divided by 9 raised to power 15. So with these two, I know you can make your practice exercise. You can also try other questions. Remember one thing, we are giving back to the society. What will a Kenyan child say that you do? Let us join hands together, like the video, subscribe on the channel as a way of giving back to the society. You might be older than grade 7 or grade 8 or grade 9. You might be out of CBC. You did Form 4 long time ago. But one thing, making a contribution does not care if you're small or big. You can still make contribution. You can give an impact. That one subscription, that one like of yours is what takes us to the next level. And with you and me, we can reach the whole country. So like, share as a holy testament.